Okay, everybody, happy Friday. Let's see, it's 1:25:19. Sorry I'm not here, but hopefully this will do the trick. Okay, so again, we're back to piecewise graph. So objective is graphing piecewise functions. Okay, piecewise functions. Anytime I get going too fast and you need to substitute to pause the video, please ask her, and she, of course, will do that for you, okay? Day 2, let's see if we can get this, okay? So I know this is a piecewise graph. It's got 3 different graphs to it, okay? What I want to do first, for me, personally, is I like to put in my border points first. So I'm going to try and put in my border points here. So I'm going to go to -5 on the x. On the x-axis, -1, -2, -3, -4, -5. And I'm going to put in a borderline, okay? Because I know this helps me figure out where my graphs go. And these are invisible lines. I'm going to go to -2 and put a borderline. I'm going to go to +2 and put a borderline. And then I'm going to go to +5 and put a borderline. 1, 2, 3, 4, 5 and put a borderline, okay? Now, first graph is going to go in the first region. Second graph is going to go in the middle region. The third graph is going to go in this third region, okay? So let's just go ahead and mark that, okay? So, f of x, same thing as y. So I'm going to have 3 different graphs. So my equations are equation 1, y equals 2. And I got that right from here. Y equals 2. F of x and y are the same thing for now. Y equals 2, okay? Second equation. Y equals -1/2 x plus 1, okay? Y equals -1/2 x plus 1. And the third equation is going to be y equals x minus 2, okay? So I want to graph all of those, but in the regions, okay? So y equals 2 is in the first region. It's going to be within here. So y equals 2 is a line up at 2, and it goes horizontally across at 2. But I only want this part of it. I want it only between -5 and 2, so there is no graph that exists on either side, okay? It equals -5, solid dot. It equals -2, solid dot. Solid dot because of the equal sign, solid dot because of the equal sign on the line, okay? Second graph. Let's see, we're going to start up at 1 on the y-axis. We're going to start at 1, and we're going to go then down 1 over 2, down 1 over 2, down 1 over 2, but of course the graph goes the other way too. So the entire graph looks something like this. That's the entire line. But I don't want all of this line. I only want the piece that's between -2 and 2. I want it right in here in the second region. So, erase, erase. Okay. This point's already been claimed. I don't need to worry about it. But this one here is going to have to be a solid dot. Okay. Third line. Let's see, we're going to start at -2 on the y-axis. 1, 2. It's a graph of 1 over 1. So I'm going to go up 1 over 1, up 1 over 1, up 1 over 1. But I really don't want all of this graph. I only want this part of it right here. Okay. And solid dot. Now, one more thing I want to talk about on this graph is domain and range. Okay? Domain. Let's talk about domain. Okay? So, domain's a little bit different because how wide is this graph? This graph goes from -5 and travels. It goes -5 all the way to 5. Okay? It goes from -5 to 5. So the domain of this graph is from -5 is less than or equal to x, which is less than or equal to 5. This graph only goes between -5 and 5. Okay? The range of this graph. Okay, reach for your range. What's the height of this graph? Well, it has a very lowest height of 0 and its highest height of 3. So this graph has a height between 0 and 3. So the range is going to be 0 is less than or equal to y, which is less than or equal to 3. Domain and range. A little bit harder. I want to add one more piece, okay? All right, let's move on to example number 2. Hopefully I'm not going too fast, okay? Slide it up. You can always pause if I am, okay? Number 2. Find a piecewise graph from this function. Okay, well, let's first of all, I have 3 different equations. Okay, I've got equation 1, which is that one, and equation 2, which is that one, and equation 3, which is that one. If I were to draw my borderlines, it looks like I have borderlines here, 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 and here. Now I like to draw my borderlines. They're invisible lines, okay? So I like to draw my borderlines so I can see it, okay? So I've got 3 different equations, and I need to make the equation for all 3 of these, okay? So let's start with equation 1. Y equals, let's see, it goes down 1 over 1, down 1 over 1, down 1 over 1. Now if I kept going and drew it all the way to the y-axis, it would have intersected -1. I erased that. But it is really y equals down 1 over 1x, and it had a -1 as a y-intercept. Okay? Equation 2, straight across at 3. Just plain old y equals 3. It's a horizontal line. Okay? Equation 3 is up 2 over 1, up 2 over 1, so it's a y equals a 2 over 1x. And it's kind of hard to tell, so let's see if I can figure it out, okay? Way down here. I can do this without graphing, okay? You ready? At a height of -3, height of -5, height of -7, height of -9. It would have crossed at -9. So what I did is I'm just going down 2, down 2, down 2, which will put me all the way at -9, okay? All right, now, we've got the 3 equations. Where are they connected? Well, graph 1 is between, let's see, -1 and 1, 2, 3, 4. So graph 1 is between -1 and 4, so we're going to say -4 is less than or equal to x, which is less than or equal to 1. -1. But that's not exactly true, because it doesn't equal -4, does it? Open dot. So it's just less than -4, okay? Graph 2 exists between -1 and 1, 2, 3. So graph 2 is between -1 and 3. -1 is less than x, which is less than or equal to 3. Okay, got it that time. Open circle, doesn't equal it at -1. Okay. Graph 3 exists between 3 and 3, 4, 5, 6, right? Graph 3 exists between 3 and 6. So we're going to go 3 is less than x, which is less than or equal to 6. Okay, it doesn't equal 3, open circle, so no equal sign. Okay, hopefully I'm going slowly enough. If not, ask the substitute to pause it at any time. All right, now let's write this like one of these, okay? Let's write like one of these. All right, so we're going to go f of x equals, you ready? Equation 1. -1 over 1x minus 1, and that's if it's between -4 and -1. Y equals 3 if it's between -1 and 3. Y equals 2 over 1x minus 9, and that's if it's between 3 and -6. That is my answer. Okay. Now, domain's kind of weird, but let's just really think about traveling along. Okay. So it starts at -4, and the graph cruises over, cruises over, cruises over. So everything's here. Even this point's here. This point's here. The only point it doesn't really equal is right here at -4. So the domain of this one is from -4 x all the way to 6. Okay, the domain exists between 4, and 6, but it doesn't equal negative 4 because open dot, okay? The range. Okay, how high is it? Well, it starts at a height of negative 3, but doesn't really equal it. It goes all the way up to a height of 3, and it actually equals 3. Even though you got an open circle here, an open circle here, it actually equals 3, okay? So it's going to go from negative 3, which it doesn't equal, up to 3. So the domain is going to go from negative 3, but doesn't equal it, up to positive 3, which it equals. So it goes from negative 3, height of negative 3, up to 3, okay? All right, turn the page. You can pause anytime you want, okay? All right, example 3. All right, so it's an absolute value graph. It's a V. So first of all, the vertex is at positive 4, negative 6. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. It has a slope of 2 over 1. So I'm all the way down here. So I'm going to go up 2 over 1, up 2 over 1, up 2 over 1. And of course it's absolute value, so it is the V symmetrical, okay? Okay, how am I doing? Now, if we look at the absolute value graph, it really, in a sense, is made up of 2 different graphs, graph 1 and graph 2. So if we have to write this as a piecewise function, we need 2 graphs, okay? So we have graph number 1, this is the one coming down. I got graph number 2, which is the graph going up, okay? So, 2 equations, right? So I need 2 equations. Right, so let's start right there, okay? 2 equations. So first of all, first equation. Let's see, it goes down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. So it's going to be a y equals down 2 over 1 x. And its y-intercept is easy to find right there at plus 2. Okay? Graph number 2 is a little harder to find the y-intercept, but we'll do it again. I'll help you find it, okay? We're going to use a little common sense. Graph number 2 is up 2 over 1, up 2 over 1, up 2 over 1, so y equals up 2 over 1 x, but the y-intercept is way down here. Now, let me do this slowly with you, okay? Wait till you're ready. Okay, right now, 1, 2, 3, 4, 5, 6. Right now, I'm at a height of negative 6, right? Down 2 over 1, height of negative 8, height of negative 10. Negative 12, negative 14. It would have to cross at negative 14, okay? And if you want a bigger piece of graph paper, if you want to just take it and regraph it on a big, huge piece of graph paper, you can get it easily, okay? Me, I can just do it by finding it, okay? All right, now, it's a piecewise graph. So where are they connected? Connected right here at 4, right? Right here at x equals 4. Okay, so graph number 1 is on the back side of it. So graph number 1 is going to be at x is less than 4, from 4 back. Graph number 2 is from over here. It's on this side of 4. So graph number 2 is from 4 forward, or x is greater than 4. Okay, one of these 2 need to actually have the point. It doesn't matter if I give it to 1 or 2. It doesn't matter, but I have to count that point. So I'm just going to give it to graph 1. Okay. Can't give it to both. Got to give it to one or the other, okay? All right, now I'm ready to make it into a piecewise graph. So we're going to write this. F of x is equal to, and I put it in my brace, I'm going to have a negative 2x plus 2 if x is less than or equal to 4, okay? And equation 2, which is a 2x minus 14, and that's if x is greater than 4. Okay? All right, I want to look at page 10 again in your journal. We did a little bit of this yesterday, but I just want to double check on page 10 that we do it again a little bit, okay? So, go to page 10. 10. Well, we've done these. Hopefully you guys are good at that. I don't really want to do these because we just did a bunch of these. You know what? We'll stop. We did page 10 yesterday. That's probably good. That's all we really need to do. So, hopefully the substitute is passing out your homework. Be nice to the substitute. You've got all period to get this done. And we'll stop right there.